There you go. Thank you. So if you are just joining, I did a little review of correlation. Here I used the Correl function, Correl function. I wanted to see how rainy days is correlated with barred owls. And to do this, oops. And then over here, I wanted to look, I used the stats pack, the data analysis pack that we installed last time, and I used the correlation function. So thank you for that reminder. I appreciate that. All right, so that's all kind of review. What's new is the combo chart. So this is the Barred Owl Rain correlation Excel spreadsheet. It's in there. It's probably not in the right module week, but if you just Control F, type in Barred, Barred, you'll find it. So I'm highlighting all this. Of course, it's being fussy. There we go. And I'm going to insert a chart. So let's show what's not effective and why you might want to use a column chart first. Okay. So trend over time, great for line chart. Not great, right? The number of rainy days, it's counting days, and by definition, you can only have 31 days in a month, 28 for some months. It's the number of barred owls dwarfs it. So they're not on the same scale. This is not an effective way of displaying this data. Another way, you might do this. Oh, I know, Melissa. I'll make this a bar chart. I'll make this a column chart here. Let's do a stacked chart. Won't that be cool? Well, not really. Again, the number of rainy days is so small, it gets it gets eaten away. It totally um this is what's called a grouped chart. I think we did this for the homework again. So let's do a combo chart. I'm going to say change chart type again. Go. It wants to give you a friendly little recommendation. That's fine. Ignore that. Go to all charts. All the way at the bottom, you got a combo chart. Let me know if you. Oh, there's people coming in. Let me know if you are unable to see combo chart or if you're having issues with this. I'll go ahead and go down to combo. So if you're joining, I'm on the Barred Owl comparison spreadsheet. I've inserted a chart for month, rainy days, and barred owls, and I'm gonna go to combo chart. Okay, it says here's a combo chart. This isn't great either. But here's how we can fix that. When you make a combo chart, you want to designate a secondary axis. Maybe that's confusing. It will make more sense when I click on it. So let's do that. So I've selected rainy days as a column chart and barred owls as the line chart. I'm gonna hit OK. So what am I looking at here? It says this is barred owls. The line is the barred owls. I got a nice little line. That's the barred owls. That number, the number for that is over here on the right. Rainy days, that's the column. The number for that is over here on the left. You can see that they really seem to be highly correlated, right? Even though they're on totally different scales, the number of barred owls is in the hundreds or the thousands, and the number of rainy days is in the tens. You can see that they correlate heavily with each other. So this picture is going to tell the viewer a lot. This says, yes, in fact, it looks like when it rains more, There's more barred owls. Not not perfectly, right? There's some exceptions. You might want to investigate why there's fewer barred owls in March, but it and why there's, in November, right? It doesn't exactly match up, but it really seems to correlate very, very well. So let's just call this barred owls versus rainy days. Some kind of descriptive title. Again, if you are just coming in or you're listening to the recording, know your audience. You want to gear your title to your audience to make your message more persuasive. Any questions on that?
Is there like a specific data type that is best suited for this type of chart?
I'm glad you asked. In fact, there is. Um, in general, when you're trying to compare two different data elements on this that are on different scales, this is really helpful to use. They're unrelated data points. So it's, when the assignment was the municipal waste assignment, right? Or you were looking at the uh, energy production in like California and Texas or whatever. Um, that wouldn't really make sense to do that because you're just looking at energy production in different states. But here you have this is your independent variable, and that's here, January, February, March. January's, okay, I'm going to switch interpreters here. 1 second. It's January's always going to have 31 days in it, no matter what we do. Feb's always going to have 21 days in it. But the number of days that it rains in January, that's going to vary. The number of barred owls you're going to see, that's going to vary, right? So these are your dependent variables. So when you want to show how two dependent variables change in relation to one independent variable, that's when you want to do it. So that was probably the most complex way I could say it. But just think about when you want to when you want to show you want to compare how two variables change over time. That's a really super effective way. What did I do? What did we do this for a lot? So we had like I work at my company, we help educational institutes, usually higher ed. We help them kind of help display their data and figure out what to do with their data. They got all this data and they don't always know how to focus in the right way. So we'll build a lot of educational models. So we wanted to build a model to show how um, attendance and grades correlated. Pretty basic stuff, right? So we looked at student attendance across the different days of the week and across the different weeks in the semester, and we looked at their completed assignments and this kind of complex score. So that's like a perfect time to use a combo chart when you're trying to compare these two variables and seeing how they vary over time. That's like an ideal use case for it. Anybody have any issues creating this chart? I'm going to see you on Friday. I can always show you in person, but it's also I'm here. You can always ask me now. Okay. Yeah, that's just me going through this. And you can choose either one. I could have flipped it and had the rainy days be the line. It doesn't matter, right? You're just trying to compare, see how they correlate. So, this is really the last time we're going to talk about charts in Excel. We're going to continue to use Excel, but for other things, and then we're going to get into Tableau, which is maybe seems scary, but it's so much more powerful and fun to use than Excel. You guys will, hopefully, most students really enjoy it. Maybe a weird thing to say about just visualization software as you enjoy it, but it's fun. Okay, so which chart should you use? It's a great question. Camila kind of hinted at this question. Um, Here's a little cheat sheet. If you want to compare categories, how much waste does California and Texas produce? How much of different kinds of waste is produced? Bar chart is great. It's a great chart to use. If you're looking at a single variable, a histogram is a great chart to use. You want to look at age distribution across a population or weight distribution or something like that. A histogram is a great chart to use. A histogram is just a kind of a bar chart. It's technically called a count plot. It's a it's a bars where you're just counting how often that occurs, and the bars are squished together. I think one of the questions I have, if I haven't asked you already in one of the assignments, is what's the difference between a histogram and a bar chart? And if you just say, hey, there's no spaces between the bars and a histogram, I'll probably give you credit for that answer. And that's really the answer, right? Um, if you want to look at percentage of a whole, um, pie chart is a great kind of chart to use. You can also use stacking bars. I can demo that. There's a way to do stacking bars to where they add up to 100%. I don't like it as much as a pie chart for that. I think it can be a little confusing, especially for people who don't know what they're looking at. I prefer a pie chart when you're looking at percentages. Percentages, pie chart. And then when you want to look at trends over time, the line chart is really going to be the key thing there. There's exceptions to all of these. You got to use your best judgment and what conveys the message best to your audience is the question you always want to be asking. Because here's the thing, if you have a dashboard, which we're going to build in Tableau, and it's just 4 line charts, that's going to bore people. People aren't going to want to look at that. And you put all this work in there. You want people to look at your data. So vary it up as well. Oh, you know what? Maybe I'll put a bar chart in here. Maybe I'll put a pie chart in here. Maybe I'll put a map in here. It's something visual to look at. It can really help to sell your story. Data is really often about trying to convince people of the point you're trying to make. Yeah. So we talked about two sort of main types of data, I believe last time, not the recording. Oh, I've got some chats. Sorry if these were like several minutes ago. Yeah, I got it. Um, we talked about numerical data and categorical data. Numerical data is just what it sounds like. It's numbers, height, weight, number of rainy days. It's all numerical data. Categorical data is categories, it's words, it's things, eye color, dog breeds, car models, all that kind of stuff, right? Those are categories. Educational level. So there's actually a third type of data which you could call date time or timed data. It's not quite numeric. It's not quite a category. It can be both days of the week. That can be a category. Months of the year can be a category. But you can also look at it as a number, especially if you look at the time since something happened, right? But anyway, it's really its own data type. But going back to numerical data, there are tables and charts that are appropriate for numerical data. We've looked at histograms already. We're briefly going to look at frequency and cumulative distributions. Um, you've seen these are pivot tables. You've seen these. They're kind of specialized forms of pivot tables. So let's see if we can do this. This is just me talking at you, so I'm sorry if it's going to be kind of boring, but we'll get through this. So imagine you're the director of public health and you are thinking of a scenario. How often do people come into these emergency rooms because they don't have a primary care physician? They just treat them as their doctor's office, right? They come in with a cold, they've got a sore arm, they've got, you know, itch somewhere, and they want to get that treated, but it's not an emergency. And people really, really do use emergency rooms for this. And it's a represents a significant load on the ER staff, and it slows everybody else down. So this is a real public health issue, right? So she wants to try to, and it's also it costs more to go to ER care, right? So she wants to try to count when this ER care is used in place of primary care. So she's doing a pilot study, a small study of 20 people who've come into the ER, and she ranks their severity of their illness. Some person comes in and they've got a slight headache or their ankle's a little sore. That's going to be a 10, maybe a 12. And then there's somebody comes in and they have a bullet wound, you know, that might be closer to a 60, right? So she assigns a rank to them based upon her expertise. I'm just setting the situation, right? So here are 20 data points, 12. They've ranked them in order, 12 through 58. And um, she's just ranked them here. She said, okay, well, I'm going to say if they're greater than 10 but less than 20, that's mild. Greater than 20, less than 30, that's somewhat mild, etc., all the way up to greater than 50 but less than 60, right? And she wants to see how frequently each of these is occurring. So this is what will be called a frequency distribution table. When you want to see how frequent something happens, not too difficult, right? Based on this conclusion, yeah, maybe, 45% to, 70% of patients are coming in with, sort of less than critical or less than very important issues. So in her small sample, she's able to show that, right? So that would be something you could demonstrate with a frequency table. I'm not showing that. I mean, there's a couple things that are important about this table. This demonstrates the part of data analysis that is domain knowledge or business expertise. Why is it? I'm going to lower my hand. That is domain knowledge or business expertise. And her expertise lets her rank these people into different categories. But we do this all the time. You see this all in surveys, right? How old are you? 15 to 24, 25 to 35, 36 to whatever. And it's always a little painful when you go up to the next age group. I'm 51. I just went to like the old person's age group. I'm like, dang. Um, but yeah, so we see this all the time, right? So in that case, advertisers group the ages into groupings that are important to them. In this case, she groups these into groups that are important to her. So interpretation is always an aspect of data analysis. And then, yeah, it's just a summary table. You want to be careful, things you want to worry about when you're doing your frequency tables. You want to make sure the groups don't overlap, right? So we very carefully said greater than or equal to 10, but less than 20. And this is greater than or equal to 20. Like it's not, they aren't both equal to in here because you don't want overlapping values. So very careful here. And a lot of thought. You want your business, your knowledge, your business expertise to go into where do you draw the line? Businesses, when they advertise to you, clearly have something in mind when they say their consumer groups are like 15 to 24, 25 to 35. To them, each of those different age groups purchase or interact with their product in different ways. Yeah, this is a really interesting point. At least five categories, but no more than 15. If you have a ton of categories, it starts to lose its value, its punch, its because remember, as I preached, if you've come in later, uh, you want your audience to be able to look at the table and understand what you're trying to convey with as little thought as possible. They even call these pre-attentive processes. You can look at it without having to think about it. If it's got 15, 20, 25 categories, it starts to get you have to think, what am I looking at here? You'll see that all the time in like Pew data, that kind of thing. Let's see. Oh, it looks like you're both pinned. Hmm. Kevin, are you gonna come up now? Okay, I'm gonna remove your pin for Sankari. Cool. All right. Yeah, you see this all the time if you're a nerd like me and you like dive into Pew data or census data or something like that, you'll see them break this all the time. They'll have like 30 categories. But that's because it's data for a specific audience, right? It's data for specialists who are looking at that data. In general, when you present to a non-technical audience, a non sort of very knowledgeable in your field audience, you want to keep it simple. 5 to 15 categories. I don't know. I put this in here, but I think it's kind of self-explanatory. The width is just, you know, that's this number, right? Three, well, it's not quite that, right? This goes 10 to 20 divided by I think we talked about range, right? Um, you can also display the cumulative frequency if you wanted to, right? So hopefully everybody understands where these numbers come from. Three, you adding six to that, you get nine. You add five to that, you get 14, 18, and 20. So it's this exact same numbers. It's just displayed in a cumulative fashion. So like I said, no practical working stuff for you guys. I hope everybody got that. If any have any questions on that. Okay. I think we've gotten into histograms enough already. I know we worked substantially with them in the first couple classes, but again, just to reiterate, I like to cover stuff that I've talked about before. A histogram just shows the frequency or the percentage. How often does something occur? One of the keys about a histogram is that they are in equal intervals. You will see the intervals need to be the same width. Whenever you create a histogram in Excel or in Tableau, as we're going to see, it will create it, each one will be 10 long or 20 long or however many wide, it's going to be, they'll all be exactly the same. Choosing the number of bars in a histogram is something of an art. By default, if there's enough data, at least 30 data points, most computer programs will give you 10 bars. That's just by default. You can imagine if you flattened it down to two, you wouldn't get much sense of the shape of the data. Whereas if you put, you know, 30 bars in there, it's not going to really tell you much either. So, there's actually, I take a whole class for my doctorate on univariate data analysis, which is univariate one data point. And histograms there's like a formula, Tukey's formula. It's insane. It's like a whole thing, but we're not going to go into that. There's no reason to go into that. But just remember, intervals have to be equal. There's no gaps. That's going to be on the quiz. And so to get a sense of what that frequency table would look like as a histogram, here you go. So each one is, I believe, 10. The width of each one is 10. So equal width, no gaps. And you can see the different distribution. So that's the big secret, right, of a frequency table is it's really just a numeric representation of a histogram. Okay. Let's take a quick 5 minute break and then we will come back. We'll talk about probability and then we'll be done at 7 Pacific time. All right. I'm going to stop share and yeah, we'll be back 5 minutes. Okay. Welcome back, everybody. Cool. Okay. Hopefully you can see my screen. Let's see, where is the whatever. All right. So we're gonna talk about probability. If you're coming in late, or I did start the recording late, we're gonna spend most of the rest of this semester talking about probability and using Tableau, which are two of the most important tools in data analysis. Excel is extremely important as well. It's why I spent 3 or 4 weeks on it. We are going to touch back with it. It's still going to remain important. But probability is the basis of AI. It's actually the basis of all machine learning. And probability is not new. The very first probabilistic models were developed in the 1840s. The chi-square test by a brewer at Guinness Brewing Company in Ireland. He wanted to test out some theories on his brewing. He developed these t-tests. We're going to use t-tests today. They're still relevant today. So I like this definition of probability. It's a language to reflect uncertainty. Feels nice in our uncertain times. It's hard to be certain about anything these days, but probability is a way to talk about how certain or uncertain we are about different things. And it can help you understand your hypothesis testing. When you begin to formulate a hypothesis, you should have an understanding of probability uh, uh, firmly established so that you can perform your hypothesis testing. Okay. So here I have some concrete reasons why you might want it. Why are we studying probability? You're like, I'm not going to be programming AI models or machine learning models. Why do I need to use this? Well, imagine you have the mean, the average, right, of a sample or a population. It doesn't matter. You take another sample and you want to say, do I think I'm going to see, do I expect I'm going to see the same mean? How much can I trust the statistic that I get out of this? 90% of people recover from this illness. That gives you a general sense of if you take any group of 100 people, you should see 90 of them have recovered on average. Another way we might interact with probability in our everyday life, if you see a forecast and it says percent of precipitation is 80%, you might want an umbrella or snow boots, depending upon the weather where you're at. In a way, we kind of use probability assessments in our daily lives. Do I think it's going to rain today? Do I think I can run this errand before I got to go pick up my kids? There might be some traffic. Might get stuck. You run through all these probabilities before you make your decisions. And even if you don't end up using probability, even if you don't end up using anything that I'm teaching you in this class, it's important for you to understand what the people who are running your data models and producing the data that you're going to use, understand how they think. That can be tremendously important. Okay, so if you remember, I said that probability was a language to reflect uncertainty. So here's some uncertainty that exists in our daily lives. Rolling a die, right? Getting 1 through 6, unless you're playing with those fancy dice, 1 through 12s, 1 through 20s, whatever. You're turning cards, pulling cards out of a deck. What's the percentage that you're going to draw a 3 out of a deck of 52 cards? When someone clicks on your ad, you're running an ad, you're selling a product. What percent of those people who click on the ad are actually going to buy it? That's a certain percent that, believe me, every marketer, everyone who sells anything online is intensely studying. Google even generate, if you run ads on Google, they will give you these statistics. How many people show up for class? Or, as I said earlier, something my company is studying is the relationship between sort of this student activity score, which is, you know, the number of assignments they turn in, the number of classes they show up, the number of comments they leave on Canvas, the relation between that and their final grades. And a lot of, hold on, we got a new interpreter here. Give me 1 second. Here we go. Boom. And many manufacturers, hold on, are interested in the average number of defects in a production lot. So this might, Amazon, um, they run AWS, their Amazon Web Services, their cloud platform. It is, I think, to this day, the biggest cloud provider, certainly in the US. And the way they were able to be so successful is they have redundancies built in. They have a data center. They have a data center that their processes can be transferred to if something happens with the first data center. They have another backup data center. They have distributed data across the entire United States and the entire world. So that if any one of them goes down, there's a backup. There's somewhere else the data can flow into and flow out of. So they're able to achieve something like 99 point whatever nine. They say like 9 nines or 11 nines or something like that. Reliability because they have so much distributed data. That's a statistic as well. That's something they have calculated. And so definitely this is statistics and uncertainty and probability are things that businesses are using all the time. Probability theory is the tool that we use to kind of understand this uncertainty. My hope is that when you leave this class, you're going to have a greater understanding of uncertainty and how to make decisions. I don't, there are people who have studied statistics. I know I asked all of you at the beginning of class who studied statistics. Some people did it in high school, some people did it in college, some people never have. That's completely fine. There's a divergence in statistics between kind of this mathematical statistics and business statistics. We're going to be studying business statistics. In other words, things you can put into concrete action, hopefully. So we need to define some terms. Again, you probably have a sense of what probability means. It's just the likelihood or chance of something happening. When we talk about probability in statistics, we might say the probability of A or the probability of an event happening. You write it like this, P and then A in parentheses, where A is the event. Probability of the person buying a product. Probability of a student attending a class. It's a probability of a discrete event. And again, something that a lot of people have trouble getting their minds around is probability does not reflect a single event. It reflects a long-term average or the long-term percentage of times. I ran this test 1,000 times. Computer models can run tests 10,000 times in a second and give you a very, very solid estimate of how often something's going to happen, right? Yes, even if there's a 95% chance that something's going to happen, that means 5 times out of 100 it's not. So again, it's the study of uncertainty. There's always uncertainty built in. The basic probability is going to range from 0 to 1. This maybe seems similar to correlation, which we studied last time, that can run from -1 to 1. Correlation runs from 0 to 1. And you write it in this fashion. Parentheses 0, less than or equal to p, less than or equal to 1. That's a fancy way of saying the probability lies between 0 and 1. 0, it is never going to happen. 1, it's definitely going to happen. In real life, you're almost never going to get to either one of these. And I say almost never. There's instances you can think of, right? But in business, in real life, when you're running simulations, your models are almost never going to be 100. In fact, if you run a model and you get a 100% probability, that's maybe a clue that something's wrong in the way you're running your test, right? You might want to consider your processes and think about it again. So continuing with our definition of terms, there's some big picture categories that we can talk about here. One is a priori, known in advance, right? Priori, known in advance. These are known probabilities. They are factual, they are true, right? A coin toss. There's a 50%, most of us understand intellectually, right? There's a 50% chance it's going to be a head, a 50% chance it's going to be a tail. A fair die, a non-weighted die, right? We know the probability. 1 out of 6 or whatever shape your die is, right? There's empirical probabilities. You observe a population of rats going through a maze, and you say 75% of them get through the maze on the first time, 25% take, 2 or more times to go through, right? That is something that you've observed, and it's based on data. Either you can gather it in many, many ways. You can do direct observation where you're looking at it. You can do survey data. It includes a wide range. Remember, these are high level categories here. So a priori and empirical, and then subjective. Your expert opinions can be very dangerous, right? Lots of people like to claim that they are experts on things. Lots of experts in one thing like to claim expertise in another thing. But in general, we do rely on expert knowledge quite a bit, but it's important to remember that because it is a probability, even experts get it wrong from time to time. So I think I mentioned this is a sort of a formal way of writing a coin toss. So um, I'm going to go through this and then we will break and I'll ask for questions and then we can go home. So the probability of a coin toss can be written as x over t, which is just the number of ways that a coin can land versus in one flip versus the total number of possible outcomes. So if you flip a coin, it's going to either be head or tail. Uh, you know, they don't really land on their sides, right? I think that's like a movie trick. But so intuitively, like I said, we know that it's going to be a 50% chance to get ahead. So you'd write that P of heads. Remember I said the A, the number in here, you replace it with the probability of the thing you're trying to measure. So the probability of getting a heads, you'd write that formally as X over T equals 1 over 2 or 50. This is like the most basic probability model we can produce. So we're going to start relatively simple and we'll get more complex, but so this is a probability of a single event occurring in isolation. 50% chance. And here I've got one, the probability of pulling a heart out of a deck of 52 cards. You've removed the jokers. You got 52 cards. It's there are 13 hearts. and there's 52 cards. 13 divided by 52 is 25. That makes sense, right? There's four suits. You'd expect a 1/4 chance of pulling out each card, 25%. That makes sense, right? Anybody have any questions on simple a priori probability? Okay. Thank you so much, everybody, for showing up. I apologize for the confusion. I'm going to put everything on the calendar so it's all in good standing and easy to understand. I will see you on Friday, and we're hopefully going to start working with Tableau, which I think you'll all like. If you have any questions, I'll be here. If not, you're free to go.
Thank you, Melissa. I just have a quick question for the residency on the module. It says 9:30. Is
I
that
got to change
this?
that. I got to change
Okay.
that. Last semester I taught it was on Saturday, and so it was at a different time. I got to change it. I will change that too right now.
So what is it's 10 to 6? Is that
10
the
to
right
6.
time?
Yeah.
Okay.
Yeah.
All right. Thanks.
Bye.
Bye.
I have a question about a data project I'm doing. So if you have time, I'd love to
Yeah,
ask you.
for sure. Anybody else? Okay, I'm going to stop recording since it's a personal project or a